Hello, Assalamualaikum, and very good day to our lecturer, Dr. Haizan. So today, me, Ahmad Khaidir, Amir Rodzman, Putera Syabil bin Sarianto, and YEXIN will present to you our project for project part 2, MongoDB for Big Data Management. So I will present you the first question, which is how do we convert the table in SQL into a document, and why do we need it to appear as in a single document, which is embedded form of reference document. So MongoDB is a database that sits somewhere between relational and non-relational database and contained within another document. Embedding is the process of incorporating a specific type of data, such as array containing additional data, into the document itself. So for our data have a plenty of relationship in the diagram in MongoDB. We are allowed to store this data and relationship using embed document. The table in RDBMS will become a collection of data in MongoDB, and we can specify the data we want to see with linkage to another entity by using aggregation method. So we can directly convert the SQL data into a JSON file, which is a structured language that is used by MongoDB. First, let's let demo to you how we convert the SQL table into JSON. So first we need to go here and show you in the database that you want to convert to. So just choose any table that you want. For example, this is the main table. We want to convert the game table. So right click, and we have the table data export wizard. Click there and click all. Make sure all the selected column that you want to export is being ticked or enabled, and click next. Okay, then you need to click JSON and make sure the directory of the, just write anything game.json, save. Okay, and then click next, and then just click next. Okay, so the table will be export. You need to wait until all the data will be export. Okay, so after finish, just click next, and you can see that 400 262 records are exported and finished. And just go to the table, to the place that you save the JSON file, and as you can see, this is the form of JSON file that we convert from MySQL. So that's only for my part. Thank you.
Okay, good morning. My name is Syabil, and I'll be presenting for the part two of our report. So the part two basically we need to perform a similar query from our project part one, and there's only in our project part one there's 10 queries that we made in the part one. However, for part two, we only pick the 5 queries that we want to do for number two. So the first one, would like to see the top 10 highest critic score games. So how we do it is basically we use the index query here, and we just take the critic score in the project section, and also we sort it descendingly, and we limit it to only one. So here is the output, and we also include the queries here. So for the second one, we would like to see the which game and publisher produce the games that highest user score. So for this one, we use aggregate. We use lookup. First one we look up from publisher, and then we sort it descendingly, and we limit it to one. The lookup is basically we look up from game here, as we can see here, game ID here, and then we look up it with publisher collections. And here is the query. So this is one of the example for the data that we have looked up for number 2. So number 3 is uh, which platform has the top 20 highest critic score. So we also use lookup for this one. So first we look up from the game the game collections. We look up with platform collections, and then we sort it descendingly and we limit it to 20. So the query is down here, and this is one of the uh, output from the lookup for number 3. So the fourth one is we want to see which publisher and game has top 10 highest global sales. So I'd say it's almost similar. Okay. For part 4, which publisher and game has the highest collection for global sales? So from our global, not global, from sales collections, we look up 2 of the collection, which is the publisher and game first, and then we sort it to descendingly, and we only take 10 of uh, the data set. So here is one of the examples for the output for number D. And here is the query. And the last one, we would like to find top 5 genre that contribute most sales in Japan. So from sales collection, we look up like number 4, we look up publishers, and then we look up for game, 2 of the collection, and then we descendingly sort and we limit it to 5. So here is the query, and here is the example that we can find. Thank you very much.
For this case, we think NoSQL is better than RDMS because NoSQL databases are denormalized. Queries are faster than RDBMS. It also doesn't have to worry about data duplication and data connections. This makes it faster for simple queries. While SQL databases support complex data queries, but database growth and complex connections slow down queries. Also, our dataset has over 50,000 data, and RDBMS showing so much data is slow. And NoSQL database doesn't need to define structure, design entity relationship, consider non-data, isn't limited by rows and columns, can easily add data types and files, and can handle all types of data. The above characteristics are suitable for agile development. Developers can skip the upfront planning, directly create the database, and quickly modify it as needed. The flexibility and adaptability of NoSQL database makes them ideal for this use case. The above is all the context of our report. Thank you.